Okay, so we had a little homework assignment from section P6. So out of these problems, do you need me to do any? Any questions on any of the P6 homework problems? Anybody? Everyone's good with square roots and exponents? We're okay there? Rationalizing denominators? Okie doke. If any questions come up, though, because all I'm going to do today is review, when we get to P6, feel free to ask questions when we get there. All right, so what I thought I'd do is sort of give you a guide to how to study. Robert, right? You just came in?
Yeah.
Let's see. I'm going to try to give you the best, set you up, to do the best on this exam that I can. So I'm going to start back in P2 and just kind of go through the types of problems that we saw in that section. And then maybe throw an example in there. Okay. All right, so section P2. Probably when you go back to this section, you're going to see, okay, these problems are actually pretty simple. Just looking at it, we kind of just went over the rules for what to do with exponents when you saw them in expressions. So some of the rules, I'll just put those off to the side. Make sure you know what to, obviously, if something's raised to this nth power, you just multiply the base of that exponent by itself, n times. However many times that is. Everyone probably okay with that rule. And then we looked at something like, well, let's say you had the same base, two different exponents. That's supposed to be an m. It's hard to tell because I wrote it so small. So you have two different exponents, same base. That rule is you just add them. All right? Now, one thing I saw, because I'm also looking at quiz 1, a lot of people sort of had trouble with, or not had trouble, just I think got confused about whether you can do a specific thing. So I'm actually just going to throw the first quiz question up here. If you remember, it was these two expressions, right? And what you had to do was just multiply these expressions. Some folks thought you had to do some distribution of some of the integers, but all you're doing is multiplying. It doesn't matter the order. So what you could do in your head when you're doing a problem like this is do something like this. You can move all the integers together, and then all the bases that are the same, move those together. And this, we have two different bases, y and x. All right, so the way I rewrote that problem, they're the same, right? Because you can move terms around when you're multiplying. It doesn't matter the order in which you do it. So now that you see it that way, it's a little easier to work with, right? Because then you do the integers. You have negative 21. Now for the x's, again, this is same base, different exponents. You just add them per our rule up here. So you have x to the 5th. And then same thing with the y's, but we'll have a negative 4. So what does a negative exponent do? Yeah. Go ahead, Kaylee. Somebody answered it, but I couldn't really hear. Yeah. You just take that term, and wherever it is in a fraction, put it on the other part, right? So in this case, really, this whole thing's over 1. So y to the negative 4 is just going to go ahead and go into the denominator. Okay? So, I mean, unless, there was no plus sign over here or anything, so it's just multiplying across, okay? Now, another rule, I guess I could just put it right next to it, would be if you have, let's say, a to the m, right? But then you're raising that to another exponent n. That rule says you multiply the exponents. Okay, I'll give you a little different one from the one that was on the quiz. Let's do 2, 3. Let's say D All right, something like this. Some folks didn't think you had to actually put that negative exponent and attach it to the integers that were within the parentheses, but you do. So what I would do on the next line, if I wanted to rewrite this, would be 2 raised to the negative 2 power. All right, because really the exponent on the 2 is really a 1. We just never write exponents of 1, because it'd just make everything messy. And then for the d variable, we're doing this rule, we're multiplying exponents. So you'd have negative 6. And then we'd be all over 3 to the negative 2, f to the negative 4. All right, so now we've basically applied that exponent that's raising everything else. Now we can go ahead and move some stuff around. Now, what's going to happen here is, I think, pretty obvious. We're basically just going to flip the fraction, right? Because the 2 to the negative 2 and d to the negative 6, they're all going to flip to the denominator. So 2 squared d to the 6. And then the denominator, 3 to the negative 2, f to the negative 4, is going to flip to the numerator. And then the only thing left to do, and I'll just put it next to it, is to evaluate the integers. I mean, you could have done that earlier if you wanted to, but I was just trying to show you how I'm thinking about how I solve these problems. All right, so that'll be 9f to the 4th. By the way, if I make a mistake, just yell it out. It's fine. Over 4d to the 6th. So that would be that answer, okay? So that's the thought process about how I go to solve those types of problems. So I would say for section P2, I'll just say applying EXP rules. Right? Applying exponential rules. So when you look at our first quiz, that's what we did in number 1. And really, there's nothing else aside from the one more topic in P2. So everything in this section was just applying rules, those exponential rules. Now, these aren't really problems, but it was the rules for what I'd like to see once you're fully simplified these things. All right, so again, I'll just read them to you because they're in your notes. And you'll see that we did that in every one of these problems. Each base appears once, okay? Meaning you don't want to leave, 2 F's or 2 D's in this last one, right? We only want to have every base appears only once. Every exponent is positive, right? We do not want to leave negative exponents. And then no power is raised to another power. Right, so those 3 things have to be fully, because all of those things I mentioned, like if you have, like, let's say in this problem we just did, if you had F's at the end, you could still apply an exponent rule, right? Because you could add the exponents. If you had a negative exponent, again, that's an operation you could do to flip it to whatever side of the fraction. And then if you had a power to the power, again, you could do it. So you're pretty much exhausting all of the exponential rules when you do this problem. Who just came in? What's your name? Angela. Got it. Ooh, I'm trying to write with my Surface pen. Okay, so that's basically one type of problem. The only other type of problem in section P2 was scientific notation. And I think this is fairly straightforward over here. I'll just give you an example. Let's say you had 50,000, right? And you don't want to write 50,000 as a number. You want to go ahead and use scientific notation. So again, I'm going to try to do the thought process of what goes through my head. So here's the decimal point, right? For 50,000 where I just marked it. So I want to get to the last whole integer in the number. So I'm going to move the decimal point 1. I tried to actually physically move here. 1, 2, 3, 4. So I moved 4 decimal places to the left to get to the front of the 5. So it's going to be 5 point, now it's going to be 0 because there's no other digit next to it. You really just put whatever digits are next to it. 5.0 times 10 to the, now the exponent is going to be positive if you move that decimal point to the left. right? And the exponent is just how many places you move the exponent. So I moved it 4. So this would be 5.0 times 10 to the 4. Okay? I mean, if any of you are business folks, you know, like if you're talking trillions of dollars, you're not going to write out trillion all the time. You're going to have a shorthand way of writing it. Okay? All right, so that's going that direction. Let's say something small like 0.00007. I'll even add a digit 2. All right, so you want to get to that first whole integer. Now we're going to move this decimal point to the right. 1, 2, 3, 4, 5. All right. Now you don't go to the 2. It's always to the first one. And then when you write out the scientific notation, you're going to include the 2. And then it's times 10 to the. And since we move to the right, the exponent will be negative. So that's 5 to the right. So it's negative 5. Okay. Now for scientific notation, that rule I said about never leaving the exponent negative, that's okay, because this is just a way of notating different numbers. All right, so it's okay in scientific notation. So in terms of section P2, that's it, folks, right? So these are the 2 types of problems. I'm going to get a different color and try to mark those every time, right? So here's like problem type 1, problem type 2, okay? So any questions about P2? Hopefully that by now, like we're like, oh, I can do that because we pretty much do it in every problem anyway. We're okay with that? All right, great. All right, so we're still on the quiz 1 topics. Okay, so now we're going to move to section P3, and I believe that was just called polynomials. Okay. Just want to keep this consistent here. All right, so what are some things we did in P3? Well, I defined everything about polynomials, and I won't review that because we talked about, you know, when you have a polynomial, it could have multiple terms. So a 2-termed polynomial was a binomial, a 1-termed was a monomial, 3 of them were trinomial, and then we stopped naming them at that point, right? So it's just... you can add or subtract a bunch of different expressions that look like, and I gave it to you as ax to the k. All right, every term in a polynomial looks like that, right? Where a is some, we call it a coefficient because it could be a decimal, but we've only ever worked with integers, which is good, right? X would be some type of variable, whatever it might be, and then k is your exponent, which again, we've only dealt with integers, all right? But you could have decimal exponents because we've already seen that you could have like something raised to the 1/2 or the 1/3. All right, so a string of these together with addition and subtraction makes our polynomial, all right? All right, so what did we do with these polynomials? Look, so far, I don't even see a problem. All right, here's the first thing. First one is, I just want to make sure the notation's the same up here. So it's adding, subtracting, and I'll just say polys, right? I won't give you real big giant ones, but we did something like 2x cubed plus x squared minus 10. And then I'll call that, we'll just say that, I won't even label it. We'll leave it like that, and then we'll say 5x cubed minus 2x plus 5. All right, so there's 2 polynomials. Okay. And let's just add them, right? So the way I showed you to add them was just, you know, just like you did any addition back in the day, whenever you were in middle school or whatever. You put them underneath each other, right? And you just add. Now, what I just did there, I suggested you not to do. I'd like you to leave a placeholder because this one here doesn't have an x squared. So I said, throw a 0x squared in there, right? And then this one didn't have an x, so plus 0x minus 10. And then this way you're lining up all of the degrees of the polynomial. And you just add vertically. So you'll get 7x cubed plus x squared minus 2x minus 5. So this would be the addition. Okay. And then when we do subtraction, I'm going to take the same two things. The only thing I'm going to do is put the bottom one in parentheses because that negative sign is going to have to be distributed through each term in the second polynomial. All right, so we have 2 minus 5 in the x third degree. So it's negative 3x to the third. And then the x squared is still plus x squared because we're subtracting nothing from it. Now this one, 0x minus a negative 2, is going to be a plus 2x. And then negative 10 minus a positive 5 is negative 10 minus 5, or minus 15. So that's subtraction. Okay? So adding and subtracting, one type. And that, yeah, I had you do that on the quiz as well. What else do we have? And then we had multiplying polynomials. All right, so we just had real simple ones like distribution. Something like 3x times, and I'm just making these up. Okay. All right, multiply that out. And again, we're not factoring yet. We're just multiplying the polynomials out. So this would be, and again, we're still using the rules from P2. Each of these P sections kind of build on each other. So we'll get 3x cubed minus 12x squared plus 15x. And then the problem's done. There's nothing else to do, okay? Sorry. All right, another type. We did FOIL. Something like 3x minus 5 times 4x plus 2. All right, hopefully by now we're like, I could do this. Because it's good that you could do this, because when we are factoring these, a good way to check to see if you get the right answer is to FOIL your answer and see if you get the original problem that I've given you. All right, so we're doing the first, right? 3x times 4x is 12x squared. And then we'll have, I'm going to do, what is it, outer? So plus 6x, and then inner, minus 20x, and then minus 10. So you even see right here, when you do FOIL, you end up getting something that, four-termer, which means if you were going the other direction here, you'd be factored by grouping, right? So it even comes out when you do the FOIL. And then you just combine the like terms, and you get 12x squared minus 14x minus 10. All right? And what else was in here for multiplying polynomials? That was FOIL. Okay, we had stuff like, again, where you use FOIL, but you might just have like 2x minus 1 squared. Here, I'll just put some dotted lines between these. You know, they're not the same problem. So 2x minus 1 squared. That's the same thing as this, right? You're just multiplying that binomial by itself. And then you FOIL. And hopefully by now we're getting really good at that coming up on this exam. So you get 4x squared minus 4x plus 1. Okay. All right. And let's see. The only other type in here, and I'm not going to give you an example because I'm telling you right now you don't have to worry about it for the exam, was if you had multiple variables in a FOIL, like if you had an x and a y term or something. But don't worry about that so much. All right, so in terms of problem types, now what I'll do is I'll put some arrows here. The two types of multiplying, really, when you look at it, would be distribution. That was like this very first example I did here. And then FOIL. And because really this last one is also FOIL. All right, so if I get my red, I'm going to start counting these up. So there's 1, 2 in section P2, and then we're at 3, 4. You know, distribution of 4 are like 4A, 4B. And that's section P3. Now that took us all the way through our first quiz. Okay? All right, and if you look at any of the homework assignments, you'll see that there are these 4 types for these 2 sections. All right, so hopefully those 2 sections, there's hopefully no issues. But at this point, I'd like to take any questions you have from P3. Hopefully I asked you about P2, but that was pretty basic. Anything from P3 that you're confused about that you would need to see before I move on? Are we okay? Remember, I can't see over here, so just yell out. We're okay? Okay, great. Moving on. Okay. We are now on the second quiz worth of material. All right, so P2, P3, they were essentially leading us up to, put a line here, section P4, and this was actually the reverse process of the things we were doing in section P3, right? P3 we're multiplying the polynomials out. P4 was about factoring them. Okay. Okie dokie. So, first problem type was using the GCF. What did that stand for, GCF? Greatest common factor, right? So let me try to find, I'm just going to try to find one. By the way, I don't know if they probably give you the odd answers, but at the end of chapter P, there's a building skills review exercises for the entire chapter. Now, the only thing you have to worry about is when you're looking at them, some of the problems you're not responsible for, but you could easily pick out some of these ones that we're doing. So if you want some extra problems to do, look at the odd ones at the end of the chapter. There'd be some, good extra problems to just check out for extra practice. Okay, so I'm looking for a GCF problem over here. And let's see if I'm seeing any. I could probably make one of these up pretty quickly. Yeah, see, they don't even have it back there because they probably think it's simple. But do I find one there? All right, here we go. Let's do 10x squared minus 5x plus 25. Here, I'm going to change these exponents. Make it a little easier. Make it a little more difficult. So because we didn't really do anything more difficult than this. So there we go. What's the GCF of that sucker? What do you get? Okay, so the rule for finding the GCF was the largest integer that divides all of the other coefficients evenly. So in this case, it would be 5, right? 5's the largest. 10 doesn't go into 5. 10 doesn't go into 25, but 5 goes into all of them. All right, so there's 5. And then it's the lowest degree of the variable. So what's the lowest degree? X. So we have 5x as our GCF. And then to get what goes in our parentheses here, it's just what would you have to multiply the GCF by to get each term. So what do I multiply 5x by to get 10x cubed? It's going to be a 2x squared. And then for 5x squared, it would be a negative x. And then we'll have plus 5. All right. So if all I asked you to do was, factor this, you're using the GCF, you're done. Now, again, you could check to see how to do this, but this is going to be a problem type we're going to do in a moment. All right. So we'll leave that alone for now. So that's one type of factoring, just finding the GCF, because we do that when we start factoring by grouping. Okay. So the next type is I'm going to do them in a specific order. Let's do factor by grouping next. So factor by grouping. Okay. And there's definitely a bunch there's definitely a lot of practice back here. So let's find a good one. how about this one? Now, how do you know it's a factor by grouping problem? What's your clue? 4 terms, right? You see 4 terms? Factor by grouping. All right, so you could try to rearrange it if you think it's easier. In this particular problem, I think it's fine how it is, right? So you start with the first group, x squared plus 11x, and again, you're finding its GCF. The integer is 1, right? Because there's nothing else that divides both them evenly. And then the lowest degree of x is x. So you take out x out, and you're left with x plus 11. Then you work on the next grouping. So you take out 5's the largest integer. And really, the lowest degree of x is x to the 0, which is 1. So we don't even put an x there because the 55 doesn't have an x next to it. So what we're left with is x plus 11. All right, so this is what you do with grouping. You bring the common term down, and then whatever's left over goes in the second binomial parentheses, x plus 5. Factor by grouping. That's it. Okay. I don't know that we need to see anymore because we're going to end up doing it again for the next types. Okay, let's see. Here we go. Now, when I gave you the notes, I started these trinomial group factoring by giving you simple ones, like something like that looked like x squared plus, I'm going to make one up, 10x. Can I even do that? Actually, I'm going to make it 7x plus 10. Will that be good? I think that's okay. Believe it or not, coming up with these on the spot isn't easy. Okay, so there's our simple one. Now, that one's easy because we don't have a coefficient next to the x squared, right? But ones that look like this, let me find a good one at the end of the chapter here, one that's not going to be too crazy. Yeah, I guess this one. Okay. Another trinomial. The only difference is now we have an 8 coefficient next to the x squared. But the process to solve these are the same. Okay? So let's actually do the one on the right first, because that one's a little bit more difficult. So what was the process? What did you have to do? You took the coefficient next to x squared, and then the last number, which was 9, you multiplied them together, and you get 72. Now, I picked this one out of factor each polynomial, hoping that we could figure out how to get 18. So what are some factors of 72? So obviously we have 9 and 8. 9 and 8 do not give us 18. What are some other factors of 72? Oh, thank God there is one. What else? Any? What do you think? Just yell them out if you know them. Like, I feel like any number under 100, you should be able to figure out the factors sort of in your head, right? Because it's just sort of the times tables. Yeah, so anything that you could do with the times tables. I learned the times tables in 3rd grade. Not sure when you learned them. So as long as you know the times tables, you could figure out factors. So this one, I'll give it to you just to, save time. I believe 12 times 6 is going to give me 72. And thank God it also adds up to 18, right? So here's what you got to do now. You got to figure out, all right, what do I have to do sign-wise for each of these numbers? Well, it looks like I'm definitely adding them up, right? Because 12 plus 6 is 18. And since 18 is positive, I'm going to have a positive 12x plus a positive 6x. So what I do in this process is just the first term, that 8x squared comes down. And then I'll ask you, which one, the 12x or the 6x, do you want with the 8x squared? Doesn't matter. I don't know if it matters in this problem. Which one do you want? Let's take a 12x. Why not? We'll leave it in that order. So plus 12x, but you could have it in any order you wanted here. Plus 6x plus 9. All right, great. This is wonderful. Now we're back to a factor by grouping problem. Let's start with the first group. I'm going to go ahead and I'm going to take out a 4, right? That's the largest integer that divides both evenly. And then the lowest power is an x. So I'm left with a 2x plus 3. All right? And then the second grouping, I take out a 3. And I'm left with 2x plus 3. Oh, there you go. Now we have a common term. And again, that's the check when you're doing factor by grouping, that you know you're doing this right. So you take the 2x plus 3 down, and then whatever's left over is your final factored answer. Now, again, you could FOIL that out and make sure you get the first answer. Now, you're going to have all class, right? So you're going to have an hour, and I'm going to hand it out as soon as you're here. You have an hour and 15 minutes. So, you know, there could potentially be time for you to go back and check these, and hopefully there is. All right, but I won't do that here because I'm fairly certain we did it right. All right, now go back to this first one. Now, we did 8 times 9 in this second one, but really, wouldn't we just be doing 1 times 10, right? So you're really just looking at the factors of the last one. But again, you could do the same thing. Now, sometimes, and again, this is the way they kind of taught me how to do it, right? You know they have to be x in the front. You know it has to be x. Right? Because the only thing that gives you x squared was if those two things are x. So now you're looking for factors of 10 that could give you 7. Because you don't even care about that first one. So factors of 10, well, there's 10 and 1, 5 and 2. That's it, right? So you know it's got to be 5 and 2. The only other thing is figuring out the signs. Well, this one's easy, right? Because it's plus 7x. So that means these both have to be positive. So you don't necessarily have to go through the whole process here, but you could. You could absolutely go through that whole process. Okay. What else? Let's see. Did that. Well, there's one more type. If you had something like what's your first clue when you see a two-termed polynomial? Yeah. Yeah, it's a difference between squares, right? So if you could take the square root of each of these, right? So let's start with the 100. Square root of 100 is 10, so the 10s go here. How about the square root of 81y to the 4th? What would that be? 9y squared. Yep, it's going to be 9y squared. And then throw your signs in here, and it doesn't matter the order. So poof, there you go. Okay. So here's what I'm going to do for P4, because I mean I'm looking at it, and that's it. I'm going to go back up here to write the types out. So we have GCF, and you'll understand that means GCF factoring, and then I'll put grouping. Then I'm calling this process of when you're given a trinomial and you go through this whole thing, I'm going to just call that trinomial. And then the last one, we'll just say diff BTW between squares. Okay, let me get my red ink out. So what we were at, so there's 1, 2, 3, 4. We got 5, 6, 7, 8 so far. 8 types of problems so far. All right. P4, anything? What do you got for me? We all right? We're good? Okay. All right, beautiful. P4. Back over there. And by the way, looking at quiz 2, that was questions 1, 2, and 3, right? Now, I will tell you this. On the quiz, I said, like, a number one, determine GCF and factor the following polynomials. Number two was factor the following polynomials by grouping. And then third was factor the following polynomials. Now, on the exam, I'm not going to give you those specific directions. I will just say factor these polynomials. But you know all the tricks now, right? You know if it's a GCF. Like if it's a trinomial and you can't do the trinomial method on it, like this first guy right here, then you know it's got to be GCF. If you see four terms, grouping. If you see a trinomial and it's only a quadratic, that's the hint here, right? Quadratic trinomials, that's when you use this method. And then different squares, well, if there's two things there, you know what to do. So I won't give you specific directions like I did on the quiz. Okay, so that's questions 1, 2, 3 on quiz 2. All right, good? Yeah, great. All right, here we go. P5. Okay, let's see what we got here. What did I call P5? Oh, yeah, rational expressions. All right, rational expressions. All I mean by rational expression is it's a fraction. And instead of just having numbers, there's polynomials in the place. That's it. Okay? Okay, so the first type of problem, which was actually the last problem on quiz 2, was reducing rational expressions to lowest terms. So I am going to attempt to find a good one here. Let's see. Yeah, here we go. So we'll just, actually, I'm going to write that here, reducing rational expressions. Okay. All right, so you'd see a fraction. Okay, so here we go. There it is. It's a fraction, two polynomials. What's the first step in any of these problems? Yeah, well, you're factoring, right? You're factoring the numerator and the denominator. So the top, now that top doesn't look like a difference between squares because their first check would be, can I take the square root of 24? Can't do it, right? So I'm going to GCF the numerator. Simple, right? And a lot of these ones are kind of simple like this, where, okay, I'm going to take a 12 out, and I have x plus 2. And then in the denominator, this is, again, a trinomial, but it's one of those easy ones. So I have xx. That 42 should be a 48, otherwise, or wait, is it a 42? Yep, it's 48. Oh, and I actually screwed this up. How can I make this easier? Sorry, I'm gonna make that a 24. Tell you, these are not easy to come up on your own. Sorry if you have to scratch that out. Now it's definitely gonna do what I thought it was gonna do. Oh, one can only hope. All right, so what factors of 24 are gonna help me get 14? 12 and 2. And since I'm adding 12 and 2 to get 14 and everything's positive, they're both positive, right? So the thing is with rational expressions, if you have a term in the numerator, and by term I could mean integer, single variable, or any sized polynomial. So in this case I have a binomial, x plus 2, in both the numerator and denominator, so I may cancel those out. Now they disappear, but they really leave behind ones, right? That's really what's happening there when you're canceling. All right, so what's left? You get 12. Oh, I'm glad this worked out too. Here's a good question. I have 12 over x plus 2. Am I allowed to cancel those 12s? Kaylee, why? Yeah, the x plus 12 is its own thing, right? So unless you see an x plus 12, you can't touch it. So just because there's a 12 up there doesn't mean you can cancel out that 12. Great. Now, what else did you have to do in these problems? And I'm not, and it's funny, I'm not sure why they asked you now in the P section, because there's sections later on that talk about finding the domain of an expression. Now, when you do these problems, I'm interested in the domain of this final guy here. So, all the domains always start with, because these aren't very complicated expressions, it's all reals or all real numbers, right? And then you look for the exceptions, if any, right? So, is there a value of x that makes the denominator undefined? And by that I mean, is there a value that makes the denominator 0? Negative 12, right? So you would just say all reals except x, oops, I already screwed up. X equals negative 12. And if you wanted to box it, that's fine. Now, just as let's check to make sure you're understanding, what if this answer came out to be x plus 12 over 12? Do we care about the denominator? I'm sorry, do we care about the numerator when we're doing domain? We do not, right? Do not care about that. So what would be the domain of this? What's that? No, not 0. So remember, the domain, all the definition of that is what values can you plug into your expression to get another value out of it that's not undefined. So can't I plug any value of x in here? Yeah, and I get another number. Does anyone know what this would look like, by the way, if you were to graph it? Because we're going to do graphing later on. So if I rewrote it a little differently, anyone know what that would look like? Something that looks like y equals mx plus b. What does that look like? Does that look like a line? Right? And a line is defined everywhere. So the answer to what's the domain here is you would just say all reals. That's it. There are no exceptions, right? Because the denominator is always defined as 12 in this case. All right? Okay, so that was the last question. Yes, Kelly.
I have a question.
Yeah.
I was confused by this, but I thought like it was just you had to look at the numerator. But on the homework, there was a problem.
Yeah.
It was x squared minus 6x plus 9 over 4x minus 12. And then you simplify it, the numerator got to x minus 3 over 4. And in the back of the textbook, it said the domain would be all real numbers with x plus 3. You don't look at the numerator.
You don't look at it at all. Because if the numerator is 0, that's still a defined number. Yeah. So ignore the numerator when you're looking at domain. And also, I think some of the homework problems, they wanted you to find the domain of the original problem too. That could have been an issue as well. But I even specified, because I was making some adjustments to the exam one. I only want the expression at the end. Okay, just the expression at the end. So thank you for asking that question so I could remind people of that. But that's the end of quiz 2. So from now on, you haven't been quizzed on the material. But again, I'm going to go through the same thing, go through all these processes. So what could okay, so there we go. So that's reducing rational expressions, but I'm going to put a little arrow and just write down domain. Okay, just so you're aware that that's part of it. Okay, so that was my first page here. So what else do we got? Okay, the next ones are also kind of just like this. Make them a little small. I don't know if that's too small. Is that green hard to see? Is that okay? All right. Here's the next type. This would be, I'm going to start right with division, because the division ones are going to let me give an example of let me find a nice good one here. Ooh, that's a nice one. Yep. How about, oh, that's perfect. Okay. So here are two rational expressions, and I'm asking you to divide. before I do anything, what do you do in this problem the first thing? Just get it over with, and so you don't have to worry about it anymore. What do you do to that divide to get rid of it? Yeah, you just go ahead and say, all right, well, I'm going to make this a multiplication problem, and I flip the second rational expression. So I have the 4x squared minus 9 in the numerator, and then 2x squared minus x minus 1 in the denominator. Okay? So there's your review for division, right? That's it, okay? You always make the divisions a multiplication. All right, so here's the review for multiplication. Again, what's the first step in these? Factor, right? Factor, factor, factor. Can I do anything in this first rational expression? Nothing. I'm just hanging out here, and I can't factor anything. There's no GCFs other than 1, so I move on. So what's in the numerator there? Oh, yeah, that's a difference between squares. So it's 2x, 2x, tree and tree, as we say in Scranton, and then you just throw the plus minus, okay? And then the denominator, this one doesn't look so tricky because the 2x and x, and this has to be 1. So what are the signs here? So we want the middle term to be negative, so does that work? You know, I'll just assume if you could run through the process and figure it out, but I think that's going to be it. Okay? All right. Now, this is what I did when I was showing you examples. Once you're fully factored, the next thing is to multiply across the numerator, multiply across the denominator. So this is what I was doing. I'll just throw a different color here. I was just drawing a line across, right? Because now I'm making it one big fraction. And that's nice because if I see a term in the numerator that's also a term in the denominator, I can start canceling. So do I have terms to cancel? Oh yeah, I got x minus 1's gone, and then 2x minus 3's gone. And then the only thing I'm left with is 2x plus 3 over 2x plus 1. And then that would be my final answer. Now, for whatever reason, they're not asking you to find domains here, and that's fine. All right, so let me just start adding to my list over here. So we had, that was reducing rational expressions, and then I'm going to say multiplying, dividing rational expressions. Okay. All right, so we did that. All right, now we're coming to probably the most, I would say the most difficult part of any of these P chapters up to this point, and this would be, and I'm gonna just put it down here. This would be adding and subtracting these things. So I'm gonna give you the types to study for, because I had a couple Zooms with some people, and some of the ones I assigned for homework, they could be tough, right? So I'm gonna just give you some of the types that I think you should focus on. And I'm gonna see if I could see any back over here. Okay, so here's a good one. Well, let me just make one real simple up. If you have these are the easiest ones, right? Because the denominators are already the same, all right? So here's what you do, right? If your goal is to get them the same. Now on this one, it's already the same, so that's good. So then you're just taking your numerators. Now, when you do this subtraction, and I see this mistake a lot, you only want to do the first term in the second numerator. But here's how I think you should write this out, because this is how I do it in my head. Subtracting, and then in parentheses, I'm going to put x minus 5. Because that negative sign has to be distributed through all the terms in that second numerator. All right, so what do I get here? Well, the x plus 10 stays on the bottom. Now, what happens to the x's in the numerator? See how that's x minus x, so they go away. But what about the 5's? It's 5 minus a negative 5, right? So isn't that 5 plus 5? Yeah? So I get a 10. Again, can I cancel those 10s out? No, can't do it. All right, so there's my final answer. All right, so make sure you could do those simple ones. Here's the next simplest type. I'm trying to make this, let's see, 4 over x minus x over 9 minus x minus 10 over x minus 9. Okay. Almost there. So again, these are easy to pick out because when you look at the denominators, they're almost the same, right? But they're just sort of looks like if we were able to reverse one of them, we're good to go. So here's what I would do. I'm going to look at this 9. I like to see the x variable first and the number last. So like x minus 9, that's my goal. I want to make them both x minus 9. So how do I make the bottom here x minus 9? What do I do? I could factor out a -1, and I'm left with, I would have an x here and then minus 9. See how that works? And then I have 4 minus x up here, and I'll just rewrite it. All right? Now, I got the x minus 9s there, but I have this pesky -1 on here. And I did this in class, and I'm going to show you again. If you have -4 over 1 or 4 over -1, are they the same? Yeah, that negative sign can travel. It can travel up or down in a fraction. So I'm going to put that -1 in the numerator. So what does that do? Well, doesn't that just make this x minus 4 in the numerator? Right? I just put this -1 up here and then basically distributed it through there. So the 4 becomes negative, the x becomes positive, and then we're in business. Now I have the same denominator, and then when I combine the numerator, I have just an x, and then it's -4 minus 10, so that's minus 14. So that's your final. Okay? I would say that's the next level up for what you're going to have to deal with. Okay? Okay so far? Okay. I'm going to give you one more, and these are the ones I think you should focus on. Let me find a nice one that's not going to be too crazy. Ooh, they're giving some good ones over here. Maybe I'll go back and find one in the chapter. Oh, these are terrible. Yeah, let me go back to P5. All right, what we got here. Ah, perfect. Here we go. By the way, this is number 72 in section P5. Because I noticed when I was going, because I went through the homework and put those homework grades up. So all 3 of your homework grades are there, so you can see what your bonus is going to be on exam 1 by looking at those. All right, so this is the hardest type that I think you should worry about for the exam. All right, first step, factor. I can't do anything with 3x minus 1, but I can with the denominator. That looks like a difference between squares. So we have x minus 4, x plus 4. All right. Minus. Can't do anything with 2x plus 1, nor x minus 4. So remember, our goal here is to get the same denominator so we could do what we did in these previous 2 problems. All right, so this was the rule I had given you, and this works every time. Right, if you had something like this, right? Now it doesn't matter if this is plus or minus, it works the same way. You would do a times d. In this case, it'll be minus c times, oh boy. Okay, we're working on c times b all over b times d. So that's what we're going to do here. I'm going to work through this exact thing because it will work every time. Okay? So let's try that. Now what I'll even do is I'll even label this. So like this one up here is A, this is B, this is C, and this is D. Right? Now you can certainly do this by finding the least common denominator, and if you're good at that, that's fine, but this will work every time. So let's just go ahead and follow this formula, because it works. So we're going to do A times D, so that's going to be 3x minus 1 times x minus 4. And then we're going to subtract, because that's what we have here. Now we're going to do C times B. Now here's this part. I'm going to put a big square bracket because I'm going to have some parentheses next to here. So C here is 2x plus 1 times x minus 4 times x plus 4. All right, so that's the numerator of our formula complete. And then over B times D, x minus 4, x plus 4, x minus... Oh, so there's two x minus 4s. So what I might do here, I'm going to rewrite this slightly. X plus 4, and then x minus 4 squared, right? Because if there's two of them, we'll just write it in shorthand like that. Okay? Now I want to label something in blue here. This is one term in the numerator, and now this is a second term. Once you get to this point, your goal is to factor those two terms I have labeled with those blue brackets. So do I have any common binomial terms in each of those? What's common? It looks like the x minus 4. So what I'm going to do is I'm going to factor out an x minus 4. Okay, and then just like we've been doing when we find a GCF, because that's what it is in this case, put what's left. So we're left with 3x minus 1 from that first term. And then I'm going to subtract. Now we have two terms here. So 2x plus 1 and an x plus 4. All over x plus 4, x minus 4 squared. All right, now that I have that out, can I cancel anything out between this x minus 4 and something in the denominator? Yeah, that x minus 4 is gone, and then I only have 1 now in the denominator. Okay. Now, I'm going to rewrite this just so it looks nice and clean to see what we have left over. We have... Okay. If I say on the exam to leave it in factored form, this is completely fine with me. You can leave it like this. Okay? I'm cool with that. Right? Because I'm just seeing if you could do this process here correctly. Now, if you wanted to multiply this out, like FOIL that, and then, see if the 3x would cancel out with some other x's and the 1, have at it. Okay? But if you wanted to leave it like that for the exam, I'm okay with it. So I'm just curious to see what would happen. So we have 3x minus 1. And then when I FOIL, I get 2x squared. So plus x plus 4x, so that's plus 9x plus 5. So what does that become? We get here it's negative 2x squared minus 6x plus 4. Yeah, so I'd rather see that you factored everything out correctly than giving me this quadratic polynomial with a negative coefficient in the front, right? But feel free. Again, it's not going to be wrong. Okay? So that's the most complicated type. So when I'm looking at the homework assignment, I think I had you go all the way to 77 on page 59. I'm going to tell you to focus. I'd like you to focus on the earlier ones. So that would be 69, 71, 73. All right, so if you become proficient with 69, 71, 73 on page 59, the exam questions you are going to be doable. Okay. Say that again. Oh, 69, 71, and 73. Okay. All right, so when I look at this section, just make sure there's nothing else. And that's it. So if I go back to my listing of problem types, we just did reducing rational expressions, multiplying, dividing, and then it's adding, subtracting. All right, so let's see where we were on problem types. I was at 8. So now I'm 9, 10, 11. Okay. And that section, P5, which also completes quiz 2, right? You weren't quizzed on multiplying or dividing or adding and subtracting. So that'll be new for you on the exam. Now the only thing that's left, I don't know what I just do with it, here it is, was P6. So this should be the most fresh in your mind. So it shouldn't take too long to go over this. So section P6, this is rational exponents and radicals. Okay? So we learned about square roots, how they work. Again, probably a good review. Here was some good stuff. So I gave you the product and quotient rules for square roots. Okay? Like if you had the square root of a times b, that's the same thing as the square root of a times the square root of b. And then if you had that similar fraction, a over b, it just basically says you could separate the square root into, you could separate all the terms out. And I warned you, at a nice big warning, you can't do that with addition or subtraction. So this is not equal the square root of a plus the square root of b. Can't do that. No bueno. Okay? So basically, you're simplifying expressions. Right? Something like, and if I go to, let's see, if I'm looking at the P6 homework, right? I'll just give you something from the notes and I'll change it up a little bit. Like if you had the square root of 16x to the 4th, and I'll make it simple, over 49 y to the 6th, right? What you could do is you could use the quotient rule, separate the numerator, separate the denominator, and then again use the product rule to separate the integers from the variables. Oh, that's supposed to be to the 6th. So what are you left with? Well, you take the square root of 16, you get 4. Square root of x to the 4th is x squared. Square root of 49 is 7. And then the square root of y to the 6th is y cubed. All right? So I'm going to call that simplifying square root expressions as a problem type. Hopefully they won't be too bad. And again, I just chose one that didn't have it, but you can have square roots left in your final answer. Went through a bunch of other rules. And what I'll do is I'll put a little arrow here, and we'll say only square roots and cube roots, right? I told you only worry about square roots and cube roots. All right, the next type. I know we're running out of time, but we're getting close. Like radicals. Make one up real quick. 2 square root of 50x cubed. So what's that going to be? Okay, minus 5 square root of 8x. Is that going to work? Yep, I think so. They're not like radicals, so what you have to do is simplify those radical expressions. So what I would do is the same thing as I did before. I'm going to go ahead and split up right? Everyone okay with that? How I split up the square root of 50x cubed? Right, I just split the integers up, split the x's up, and then I'm going to do the same thing over here. All right, so let's see what we have. We have a 2 times the square root of 25. So square root of 25 is 5, so 2 times 5 is 10. And then the square root of x squared is x, and we're left with 2x. Now this other one is 5 square root of 4, which is 5 times 2, which is 10, square root of 2x. All right, so what you could do here is, here, I'm gonna cheat here, and I'm gonna put an x here, and an x here, and an x here. Because then what would you get here? Again, I made this up, and you get 0, right? So if you have a common radical, you could treat that common radical like its own variable, okay? So just treat them like you could add, subtract those things together. So I'll call that a problem. That's like radicals. All right, like radicals, we did a bunch of those. Okay. I'll just, again, because this is so fresh, if you had something like 1 over the square root of 5 plus 2, and I asked you to rationalize the denominator, right? What do you multiply this by? What was the name of the thing? Wasn't it the conjugate? Is that what you're going to say, Kelly? Yeah, conjugate, which is, it's the same thing that's in the denominator. You just change the sign, and yet to do the top as well. All right, so you're going to FOIL on the bottom, which is going to remove the square root. So let's see what we have. We have the square root of 5 plus 2 in the numerator, and then we have 5 plus 2 square root of 5 minus 2 square root of 5 minus 4. So you're going to see the radicals here cancel, and we're left with the square root of 5 plus 2 over 5 minus 4, which is 1. So my answer is square root of 5 plus 2. Now, in these problems, you could have stuff in the denominator, but sometimes you don't. Okay? So rationalizing the denominator. I also had you rationalize the numerator, but I would like you to just worry about rationalizing the denominator. And there's only one other thing that we did that I'd like you to be aware of, and that would be, I'll put it over here, if you had very simple looking exponents. So let's say we had 2x raised to the 3/2 power. Okay? 2x raised to the 3/2. Tell me, because we just did this Tuesday, what does that mean to be raised to the 3/2, right? What does the bottom part of that fractional exponent mean? Yes. Okay, so the 2, though, like this guy here, is the type of root, right? So I know this is going to be a square root. And then inside the square root is whatever, this is. And it's whatever the numerator of the fractional exponent is what you're raising the thing to. So let's see what we have. I'll just do this real quick. So the square root of 8, right, because 2 to the 3rd power is 8, and it's x cubed. And then you simplify from here, which becomes a problem we've already done. So we'll have square root of 4, square root of x squared, times the square root of the thing that's left is 2x. And then you have 2x on the outside times the square root of 2x. So those types of problems. And they're not going to be crazy. They'll be very simple like that, just so I know you understand how to work with a fractional exponent. So here's what I'm going to put. The last one is fractional exponents. Now, let's see. Make this red. What number were we at? We were at 11. This is perfect. 12, 13, 14, 15. You have 15 problem types to study. So that was my advice on every quiz. identify all the problem types, which I've done for you here, and go through them one by one and say, oh, well, I'm good at this one, this one, this one, this one. I'll spend less time on those, and then go ahead and focus on the problem types I need to practice. Okay? Is that making sense? Now remember, this is shared on D2L, so if you want to go back to here and see those problem types, they're there. And this video is also going to be up later this afternoon, so if you wanted to watch it again to go through some of the explanations I gave, go for it. Otherwise, have a great day. And Tuesday, exam day. You will be allowed to have a calculator, but again, it can only be a calculator that will not reduce expressions. Okie dokie. Tomorrow and Monday, I have time. So if you do want to try to meet for office hours over Zoom, I'd be completely fine with that. Okay? Awesome. All right, wipe off your chairs. You guys know the drill by now. Yes, sir.
I used this calculator.
Let me see. Let's see. I don't know. Do you know how to?
It's like a graphing calculator.
It's graphing. I don't think this does it. Like, I don't think it reduces rational expressions. Let me just see. Is it a touchpad? Oh, it is. Let's just see. Add calculator, graphs, geometry, spreadsheet, statistics. Yeah, I think you're okay.
Okay.
Yep.
Thank you.
You're welcome.